We're living on the edge of a new kind of revolution. And I'm not talking about steam power or silicon chips. This one's built on the very fabric of reality itself. It's the quantum revolution. And honestly, it's probably going to change everything. Let's dive in.
So just take a look at this thing. What you're seeing is the IBM Quantum System 1. It totally looks like something out of a sci-fi movie. And in a lot of ways, it is. But the most futuristic part isn't the slick design. It's the fact that this machine, unlike every single computer you've ever used, doesn't think in simple zeros and ones.
Okay, so if it's not using zeros and ones, how does it think? To get that, you kind of have to forget everything you know about normal computers. We have to learn a completely new language, the language of the quantum world.
To really understand this machine, we have to start with its most basic part. It's not a bit, it's what's called a qubit. And trust me, that one little letter change makes all the difference. So, on the one hand, you've got your regular old classical bit. Super simple. Think of it like a light switch. It's either on or it's off, a 1 or a 0. It's definite, predictable. But then you have the quantum bit, the qubit. And this is where things get weird. A qubit can be a 0, it can be a 1, or somehow it can be both at the exact same time. It's just floating in a cloud of probability until the very moment you look at it. This superpower, really, this ability to be in many states at once, has a name: superposition. Imagine an electron. Instead of just spinning one way or the other, it can be in a mix of both spins at the same time. And that's not just a fun analogy. According to quantum mechanics, that is what's literally happening. And this sphere is a brilliant way to visualize it. It's called the Bloch sphere. Now, if a classical bit can only be at the very top, the North Pole, for a 1, or the very bottom, the South Pole, for a 0, a qubit can be at any single point on the entire surface of the sphere. That means there are infinite possibilities for just one qubit, and that is where quantum computers get their mind-boggling power.
Okay, so let's take a breath. This all sounds incredibly strange, right? Why on earth did scientists have to come up with such a bizarre, counterintuitive way of looking at the universe? What was so wrong with the old rules?
Well, the short answer is that around the start of the 20th century, classical physics, Newton's laws, the stuff that explains falling apples and orbiting planets, it just completely stopped making sense when we started looking at things that were really, really small.
And this right here, this is the experiment that basically broke physics. Scientists fired single electrons one at a time at a wall with 2 little slits in it. And what happened was, well, it was impossible. The electrons left a pattern on the other side that you would only get from a wave. It was as if each electron went through both slits at the same time and then interfered with itself. So, is an electron a particle or is it a wave? The crazy answer was yes. But believe it or not, a particle being in 2 places at once isn't even the weirdest part. The rabbit hole goes way deeper. We're now getting into what Albert Einstein famously called spooky action at a distance.
This spooky action has a proper name: quantum entanglement. It's what happens when you link 2 particles together. Their fates become connected in this really deep way. So if you measure something about one particle, you instantly know the same thing about the other one, even if they're on opposite sides of the universe. Now, Einstein, he hated this idea. Hated it. He thought nothing, not even information, could travel faster than light. And this instant connection seemed to break that ultimate speed limit. He was sure quantum mechanics was missing something, that there was some hidden information we just couldn't see yet. So this debate raged for years. Was Einstein right, or was the universe really this weird? The whole thing came down to a mathematical showdown, a sort of line in the sand between the classical world we know and the quantum world we were discovering. This is a version of that test. It's called Bell's inequality. Now, you don't need to understand all the math. Just think of this formula as the rulebook for our normal universe. It sets a hard limit, a speed limit, on how connected 2 particles could be, if Einstein was right. So the big question is, what happened when they actually ran the experiments? Well, they measured these entangled particles, and what they found was that reality completely tore up the rulebook. The results shattered the inequality over and over again. The math basically said that something like 0.500 had to be less than or equal to 0.292, which, of course, is impossible. Einstein was wrong. The universe is spooky. And this wasn't some fringe theory either. this is a huge deal. In fact, in 2022, the Nobel Prize in Physics was given to the 3 scientists who ran the experiments that proved entanglement was real, proving that Bell's inequality was violated and kicking off this whole new field of quantum information science. So, okay, we've established that the universe is governed by these bizarre, spooky rules. The next logical question is, so what? Can we actually do anything with all this weirdness? And the answer is a huge, resounding yes. This is where the fun begins. And here we are, full circle. Those 2 properties that seemed so strange, superposition and entanglement, they're not just scientific puzzles. They are the twin engines that give quantum computers their revolutionary power. They let these machines solve problems that are literally impossible for even the most powerful supercomputers we have today. So why should you care? Because this power could fundamentally change our world. We're talking about designing new medicines and materials, atom by atom, creating communication networks that are physically impossible to hack, pushing AI into a whole new era, or tackling huge problems like climate change by running simulations with a level of accuracy we could only dream of before.
And this isn't science fiction anymore. We're actually moving from these abstract ideas to real-world results. Let's just look at one example of how this could completely reshape our lives.
Let's talk about medicine. Right now, a lot of drugs target one specific protein. It's effective, but it's also a bit like trying to fix a complex engine by just messing with one screw. What if instead we could simulate the entire complex system of a cell, all at once? Quantum computing could make that possible, leading to what some are calling cell-centric therapeutics.
I mean, the implications of that are just profound. Imagine a future where treatments aren't blunt instruments, but are custom designed by a quantum computer to perfectly interact with a disease on a fundamental cellular level. That's the promise of putting the quantum world to work for our own health.
And that brings us to the final and maybe the most mind-bending question of all. Our brains, at the end of the day, are made of atoms and molecules that follow these quantum laws. So could quantum information be the missing piece of the puzzle to understanding one of the deepest mysteries there is? Human consciousness itself. We absolutely do not have the answer yet. But with the quantum revolution, we're finally building the tools to seriously ask the question.